BorgWarner versus Garrett, the 1,000 horsepower contenders. Let's put these guys side by side. Let's go over the features. Let's delve into these two turbochargers. Today, you're going to learn something. Hey everybody, welcome back. Here is a video for you on another comparison between BorgWarner and Garrett yet again. Today we're talking the 1,000 horsepower mark and what Garrett have got to offer and what BorgWarner have got to offer, and we're going to show these two side by side. We want to talk about the features, we're going to talk about the technologies, and if you guys haven't seen an in-depth comparison component for component side by side between Garrett ball bearing and BorgWarner ball bearing, I'll post those two videos, part 1 and 2, down below in the description. Go and check them out and let me know what you guys think in the comment section below. Let's move on to the two 1,000 horsepower capable turbochargers from Garrett and BorgWarner. All right guys, so we've got our BorgWarner set up on the left hand side over here. This is your 8474 Black Series, 950 horsepower capable, claimed by BorgWarner. And on the right hand side we have the Garrett G35-1050, which is 1,050 horsepower capable turbocharger, claimed by Garrett. Now, let's first start off with the most obvious. What is the size between the two rotating assemblies? Garrett's compressor inducer is 68 millimeters and 84 at the X-juicer, as well as BorgWarner, exactly the same size, 68 inducer, 84 X-juicer. On the turbine side, Garrett has got a 68 millimeter inducer blade and a 62 millimeter X-juicer blade. On the BorgWarner, we have a different story. We've got a 74 millimeter inducer blade and we have a 64 millimeter X-juicer blade. This blade on the BorgWarner side is manufactured from gamma ti or titanium aluminide. It is 35 to 40% less in weight than the Inconel blade that, should I say, the MAR M247 blade. That's the new material used on the G series turbochargers. It's no longer Inconel 713LC, it's MAR M247. It's still a super alloy, but with some slight differences in the material content, the structure, ductility ratings, thermal sealings, etc., etc. Very similarly sized in terms of the turbine blades, but the major difference being that Garrett have got a scallop cut out between the blades, which is basically a cutout at the base where your inducer blade sits. I'm just going to point to it with the back of a vernier over there. And the BorgWarner has got a solid disc back. The reason that Borg have got a solid disc back is purely because of the fact that the design internally to the turbine housing is somewhat of a mixed flow turbine as opposed to a pure radial design on the Garrett. There are other benefits that I have discussed in the video where I compare side by side all of the technologies between Borg and Garrett. As I've mentioned, they're down below in the comment section. Go and check them out for some more information on that. Garrett have got a backplate and bearing housing cast as one piece. So does BorgWarner. Garrett have manufactured theirs out of iron. Borg have manufactured theirs out of aluminium and or iron. You can obviously choose which one you want. Aluminium being a much better option for obvious reasons. Thermal characteristics and obviously much lighter. The Garrett ball bearing cartridge design in terms of the outside dimensions and the total height, size of the balls, and the overall design has never changed since its inception. The only difference is it runs an 8mm cartridge now as opposed to the previous 6. The BorgWarner design runs a much thicker wall. It's got much bigger cooling jackets inside of the bearing housing as opposed to the Garrett model. And from a reliability point of view and a thermal load point of view and a thermal heat management point of view, the BorgWarner far exceeds that of the Garrett. Garrett come with all of your fittings, so your inlets on your oil and your water on both sides are already included, as well as 2 plugs. Obviously you have one inlet in terms of water and one outlet in terms of water, and the other 2 ports are obviously blocked. You can swap these around as you wish. Exactly the same thing on the Borg, except the actual inlet fittings are not present. That you can purchase separately with a hardware installation pack. Nice thing about that is you can choose the hardware installation pack specifically for the material bearing housing you're using. If you're using aluminium, you get a load distribution plate or shim, which sits between the aluminium bearing housing and the clamping plate. And then at the same time, you get all of your inlet fittings, outlet fittings, V-band, clamps, flanges, gaskets, etc., etc. No option that you can purchase all these things from the Garrett side of things. You have to purchase each of those items individually per part number. Moving on, let's have a look at the design of the compressor wheel. You have a 9 main blade compressor on the Garrett, and we have a 7 blade splitter on the BorgWarner. BorgWarner, I believe, were the guys that pioneered the extended tip technology. Obviously, this blade has got an extended tip, and Garrett followed suit. Garrett also has an extended tip, but it's slightly different. It doesn't actually have a tip that extends outwards to a sharp point, and then your inducer radius profile from the exducer to the inducer begins. It is slightly different, so it will extend, and it basically rounds off at the edges at the widest point on the extended tip. It's not as aggressive as the BorgWarner is. You have a boost-only source as well as a speed sensor port built into the housing on the Garrett. This is an AR75 TO4E family housing. Same thing goes for the BorgWarner. There is your speed sensor port. You have a diverter valve built in. You have a boost control solenoid built in. Fully machined intake tract on both of these, and you do not get any diverter valve or boost control solenoid included in the Garrett. BorgWarner comes in 2 different options. You have an externally gated or free floating option, which will basically be a turbine housing without an internal swing valve. On the Garrett side of things, you get external only. You only get a V-band in and V-band out housing in various AR, so a 61, 83, and slightly larger from there. On the Borg, you get a nice range of different housings. I'm just going to take this off to show you. Here's a T4 inlet flange, which is twin scroll and twin port on your internal gate structure over there, running a 42mm swing valve and a 76mm V-band outlet. This is an AR83. You get an AR92, 105, and 141, I believe. I stand to be corrected on the 141. It might be a 142, but be that as it may, it is quite a large turbine housing. Here's the T3. This is a T3 inlet flange, V-band out, single port, 42mm swing valve, all built in, stainless steel, beautiful housing. That is pretty much the BorgWarner range next to the Garrett. Now, looking at it from the angle that the camera is showing you right now, doesn't it look weird? The total height or length, if you want to call it, of these 2 turbochargers is very, very different. If you look at these 2 turbochargers head on, you'll find that the BorgWarner is a longer turbocharger because of the fact that it is internally gated, and this entire piece over here needs to be added to the turbine housing, which is approximately 50 or 60 millimeters, which makes this specific turbocharger with this specific housing quite a lot taller than the Garrett unit. The free floating turbine housing on the BorgWarner pretty much levels the playing fields, and although will be a little bit shorter in terms of total height, will still be a little bit taller than the Garrett, purely because of the fact that the compressor housing is that much taller, because you've got an integrated diverter valve with all of the port structure inside, as well as the mounting brackets and casting extensions for your boost control solenoid. So talking about dimensions, 4-inch inlet, 2.5-inch outlet, 4-inch inlet, 2.5-inch outlet. So 102 mils, 102 mils, 63, 63. Both hose clamps on the outlets, both hose clamps on the inlets as well. The only difference between the 2 speed sensor ports is you have to drill the final little bit through on the BorgWarner. The Garrett already has been drilled for you and comes with a little bung or plastic seal, which basically fits inside there with your little O-ring. On the Garrett side of the turbocharger or the turbine side, you have V-band in and out. This is a 76mm inlet and a 90mm outlet. Correct. So we have got a 3-inch inlet and a 3.5-inch outlet. 90mm is 3.5 inches, yes. So that is pretty much where we're sitting with the BorgWarner range versus Garrett. The nice thing about Borg is the fact that you can purchase 3 different actuator spring pressures. One would be a low boost, medium boost, and high boost. And obviously you get your different bracketry and all of these little bits and bobs that you can customize your turbocharger setup for your build. Okay guys, so let's go over the compressor maps real quick. On your screen now you'll see some digital maps loaded. On the left hand side is the EFR8474 and the right hand side is your G35-1050. Now, I don't go into too much detail on the compressor maps. I just discuss the absolute basics or the obvious features of each of these turbochargers and their maps. First of all, Garrett claimed this turbocharger to be 1050 horsepower capable. The map says otherwise. It barely touches the 100 horsepower or the 100 pound per minute of airflow mark at approximately 2.6, maybe 2.7 bar boost. And obviously, as you start increasing the boost from there, it starts to fall away quite drastically. On the 8474, you reach a 950 horsepower capable or 95 pound per minute of airflow according to the map from around about 1.6, 1.7 bar boost, and it maintains that all the way up to 2.8 bar boost. So, 1.2 bar worth of 950 horsepower usable range in this area here. The maximum efficiency on the Garrett is a 78%. Ignore the physical number, and I'll tell you why just now. But that starts at 1 bar gauge pressure, which is over there, and it intersects the graph right there. Where it intersects, you're looking at approximately 500 horsepower capable airflow. And on the BorgWarner, you will reach a maximum efficiency number of 75% at 0.8 bar boost, and at that point you're doing about a 405 to 410 horsepower around about there. The maximum efficiency island on the BorgWarner lasts from 0.8 bar all the way up to 1.8 bar. So it's about a bar's worth of efficiency total height in the map in terms of a P to C ratio. On the Garrett, you start at a bar and you end at approximately 2.3 bar boost. So that's about a 1.3 bar, 1.4 bar boost worth of usable P2C in its maximum efficiency. Where its maximum efficiency maxes out is at approximately 800 horsepower, just a touch before, probably 790. And on the BorgWarner, you're sitting at around about 625, 630 horsepower at its maximum efficiency, at the top of the maximum efficiency island. Right, let's have a look at a few other things that jump out at us. First of all, let's turn to the Garrett again. At approximately half a bar boost, which is approximately that point there, the map starts at, forget about the actual horsepower rating, but as you move across this half a bar line, you'll see that the turbocharger speed will be between those two lines there. That's 50,000 and 67,500. So what's halfway between that? Let's say about 55,000, 56,000 RPM, maybe 57,000 RPM, and will run all the way up to approximately 85,000 RPM. Now, how is that possible? Because the boost pressure is exactly the same. Well, let's go into this a little bit. First of all, let's say, for example, you've got an engine that will start making half a bar boost at 3,000 RPM. As the engine revs through its rev range, its demand on airflow increases. You have a wastegate maintaining half a bar boost, but as the engine revs, it will consume more and more and more air from the turbocharger at the same boost pressure. But in order to be able to maintain that pressure, the speed of the turbocharger needs to increase. Right, I'm not going to delve too much more into the technical details there, but have a look at the range of speed that you're using at half a bar. Let's go back to the BorgWarner and do the same thing. So at half a bar boost, that's actually 0.6. So between these two, you're looking at about 52, maybe 54, 55,000 RPM. And as you go across, you will get to a maximum at the same boost pressure of around about 70,000 RPM. So it's slightly less. It's about from 85 to 70. It's 15,000 RPM less. That is a considerable amount of turbocharger speed that the BorgWarner saves as opposed to the Garrett. So the Garrett seems to be working harder in terms of its rotational speeds. Let's go to where the maximum power is produced on the BorgWarner. 950 horsepower at approximately 2-bar boost. So you'll start seeing it at about 1.8. Let's just run it off at 2-bar boost. At that point, you're going to be running at 117,000 RPM. And on the Garrett, at 2-bar boost, you are going to be running at approximately 970 horsepower at 130,000 RPM. That's a lot more in terms of speed. It's 13,000 RPM more at the same boost pressure. Let's go higher. Let's say we wanted to run this turbocharger at 3-bar boost. Okay, well, that's 3-bar gauge pressure over there. You're pretty much out of turbocharger. Let's go down a bit. Let's go to 2.5 bar, which is that there. 2.5 bar gauge pressure, 3.5 at absolute. At that point, you will basically make 940, 930 horsepower. And on the BorgWarner side of things, at 2.5 bar boost pressure gauge, you will make 950 horsepower. So you're making slightly more than the Garrett, but you're doing it at approximately 117. That line will cross over there, but 117,000 RPM. Once again, considerably less speed compared to the Garrett. Now, let me ask a question, and I'm not going to give you the answer. I think you'll get the idea. 78% efficiency, 75% efficiency, much higher rotational speed than the BorgWarner. Does this not mean that the BorgWarner's rotating assembly is more efficient? It runs a 75% at a much lower RPM than what Garrett does. Go figure. Right, so if you look at these maps, what is the usable P2C area? Okay, your boost pressure area at maximum horsepower or maximum flow. 95 pounds per minute starts at about 1.6, 1.7 bar boost, or 1.8 bar boost, and it goes all the way up to approximately 2.8 bar, 2.7 bar, around about there. Garrett, you have maximum power rated at 100 pounds per minute of airflow, which they claim is 1,000 horsepower, but let's go up to 2.8 bar boost, which is approximately there. You're not making anywhere near the maximum. You're actually under 900 horsepower. So the higher you boost the Garrett, the less power it makes. After around about 2.5 bar boost, you just start losing power drastically. So from 2.5 to 2.7 bar, you're losing about almost 100 horsepower. So yes, the efficiency percentages seem high, but the airflow at those high efficiency islands are very, very low in comparison to the BorgWarner. So which would you choose? Right, the next thing we want to talk about is the obvious elephant in the room. What are the cost differences between these two turbochargers? They both have features that some would like on the Borg and others would prefer on the Garrett. You get your die-hard Garrett fans, your die-hard BorgWarner fans, but let's talk about costs real quick. Let's compare the pricing with regards to the EFR8474 black internally gated with the more expensive aluminium bearing housing and a high boost actuator and installation kit, your hardware installation kit. The pricing is probably around 5 to 10% cheaper than the G35-1050 with no options. Now that would be a turbocharger which is externally gated or free floating. You would need to go and buy a wastegate. That's $300, $400, maybe $500, $600 depending on the size you choose. Obviously we're not comparing the cheap Chinese paperweights to proper products. That you save on the BorgWarner. You need to go and buy a blow-off valve. Another $200, $300 depending on what you buy. Once again, no cheap Chinese knockoffs. BorgWarner already has a diverter valve built in. Yes, it's plastic. It works well. You'd need to go and buy, let's say for example, you go and buy a boost control solenoid, a Bosch or a Denso or a Mac 2-port or 3-port solenoid like the BorgWarner offers you, except yes, it's not a Mac, it's a 3-port solenoid nonetheless. You'd need to go and spend money on that, $50, $60 once again. So there are a lot of other things that you would need to go and purchase on top of the turbocharger if you go the Garrett route. You would also need to fabricate additional piping from the manifold to the wastegate, and from the wastegate down back into the downpipe or a screamer pipe. You have less geography to actually work with once you've installed a wastegate and all of its piping and routing, as opposed to an internally gated turbo. Yes, the BorgWarner is slightly longer, but the actual physical dimensions in terms of its diameter being internally gated is pretty much as close as damn it to the Garrett product. So from a cost perspective, the BorgWarner actually shines through, and it shines through quite a lot. You're probably talking an extra $1,000 safely that you'd need to spend after you've purchased the Garrett product as opposed to the BorgWarner, based on the equipment that is already included with the BorgWarner product. Right guys, so that's a little bit about the compressor maps, and obviously we've compared these turbochargers side by side. I never brought up the free floating turbine housing to compare on the table from the warehouse today in terms of the height of the two turbochargers with the same type of turbine housing. So obviously the BorgWarner seems a lot larger in terms of its height or width of the turbocharger, but that's purely because of the fact that it's running an internally gated housing. The externally gated or free floating turbine housing pretty much brings those back down to the same level, obviously, except for the fact that the diverter valve is built in as part of the compressor housing, which obviously has to be installed in somewhere. So it will be slightly taller, but probably by about 30 millimeters or so, an inch and a quarter, whatever the case might be. So it's neither here nor there. The Garrett design has pretty much remained constant since the very first GTX range was released. All they've done with the G series now is revise the aero on the turbine side and the compressor. The overall sizes, turbine housing and compressor housing designs have remained. They've increased the AR, in other words, the internal structure or the volute of the compressor housing to be able to cater for the flow of the larger compressor. The size and the overall design of the turbine wheel in terms of the radius profile, etc., is exactly the same as the very first GT35-1050 with a cast 6-blade splitter compressor. The bearing housing is changed purely because of the fact that they've now gone and incorporated different water cooling and a V-band attachment to the turbine housing. But the overall design has pretty much remained quite constant over the years. BorgWarner has also, the design of the actual EFR was first introduced around 2010, 2011, and has remained more or less the same, except for aerodynamic design changes on the compressors. And Garrett have gone through GT, GTX Gen 1, GTX Gen 2, and now G series, yet the very first EFR8474 with one compressor aero change is still able to compete with 4 family revisions later and directly and head on. So if you look at the actual compressor maps and some of the features I've shared with you today, depending on the size of the engine and what sort of boost pressure you want to run, you will notice that the Borg has actually got quite a bit more to offer in terms of a range of different engine sizes and boost ranges that you'd like to use. The compressor map is wider, it's taller in terms of the usable P2C, the usable boost pressure on the left-hand side. It runs at a slower speed. It is more efficient based on the fact that it is able to produce the airflow it does at a much lower rotational speed than what Garrett can. Both are great products, both are OEM manufacturers, both are proven. Garrett's bankrupt. I hope they pull out of that quite soon, because I doubt there's going to be new products being released anytime soon. But be that as it may, I hope that's been informative. I hope you guys have learned a little bit about the 2 different turbochargers in the 1,000 horsepower claimed bracket. If you have any other questions, please post them down below, interact with us, like, subscribe. Catch you guys next time.